and you guys will see this again on your quiz, says how many different types of solutions do systems have? So what are the options when it comes to solutions? Huh? No, you're thinking of what kind of line. I'm saying, like, when we graph two lines, how many solutions can we have? Yeah, okay, so you can have problems where there are no solutions. If the two lines do cross each other, then there's one solution. And then if the two lines are exactly the same, you have infinitely many solutions. So those are your possible answers as far as like how many solutions can you have. And then it says, what do those lines look like when graphing? Okay, so if there are no solutions, meaning they do not cross, your two lines have to be parallel. Okay, in order for there to be one solution, what has to happen? The two lines have to cross each other. So their solution would be the ordered pair of where they cross each other. And then for the infinitely many, it has to be the exact same line twice. So like you'd have a line, and then when you graph the second one, it falls right on top of it. So these two would be the same line, meaning that there are infinitely many solutions. Okay? That same question you are going to see again on Monday on your quiz. Okay, so you need to make sure that you have those written out and you have everything drawn there on the second part. Now at the bottom, they have systems of equations, okay? So the question up here was to prepare you for numbers 2 and 3, and then I think also numbers 4 and 5, and 6. So for problem number 2 and problem number 3, everything is in slope-intercept form, okay? So these are going to be your two easiest ones because we don't have to move anything around. We don't have to change it from standard form to slope-intercept form. We're just ready to graph. So starting with the first equation, we're going to plot the -5, and then our slope is -1/1. So how do you plot your points if it's -1/1? Where do we go? We go down, right. So you're going to go down 1, right 1, as many times as you can, which is quite a bit. But then I always expect you guys to switch directions and go the other way. So instead of down right, I'm going to go back to where I started and go up left. And there are lots of points that way. And once you have those plotted, you want to go ahead and connect them. Look, if you guys want any chance of passing that quiz on Monday, you better be off those phones and you better be writing this stuff down. If you fail on Monday, that's all on you. Now the second one, I'm going to start at +2. And my slope this time is 4/3. And since it's positive, we are going up and right. So I'm going to start by counting up 4, right 3, up 4, right 3. I can do that twice. but I really do want to see where these two lines are going to cross. So again, it's important that you guys go the opposite direction. I'm going to go down 4, left 3, and then you can see that's where they're going to cross. But I kept going. Because you always want to make sure that your line extends edge to edge. That just makes it a lot more accurate. Okay, so then once you actually have those graphed, if they cross, you have to write the ordered pair of where they cross each other. Where do they cross at? -3, -2. Good job. So when you're solving a system of equations, you're looking for the coordinates of where they would cross each other. So you have to put the ordered pair when you're done. And then I'm going to do the exact same thing on number 3. I'm going to graph each line, and I'm going to see if they cross each other. This one starts at -5 and then has a slope of -1/9. So if it's -1/9, we should be going down and right. Well, do we have enough room to go down 1, right 9? Yes, but we can only do it once. So down 1, right 9. Do I have room to go up and left? Yep, but just once. So up 1, left 9. That was the top line, top equation. So then for the bottom equation, we're starting at -2. So I'm going to start here. But then if you guys noticed, see how the slopes were the same? If slopes are the same, shouldn't they run parallel to each other? They should. So I'd go down here and I would go down 1, right 9, or up 1, left 9. And when you connect these, if your two lines are parallel, we obviously cannot write an ordered pair of where they cross because they don't cross. What do we write instead? No solutions. If they are parallel and they don't cross, you have to write no solutions. Is everybody good with those before I turn the page? Okay. Number 4. The top equation that says x equals 6, what kind of line is that going to be? Vertical. As long as it just starts with x, that is the only time that you will put your first dot on the x-axis. So you plot that on the x, and then it makes a vertical line. So all you have to do is put your ruler down and just follow the grid line. You don't have to plot any more points. Just follow the grid line. Now the second equation, the 4x minus 3y equals 6, that is standard form. That is not the form we need it in. So what is the first thing that we move? The x term. So we're going to subtract 4x from both sides. So negative 3y equals, and then we usually put the x term first, so negative 4x plus 6. Remember, you can't actually subtract those two. You should have 3 terms here. And then we're going to go through and divide everything by what? Negative 3. So now we're going to end up with an equation that says y equals 2 negatives make positive 4/3 x, because those 4/3 will not reduce. And then what's a positive 6 divided by negative 3? Negative 2, you say? Good job. Yep, negative 2. Now that we have it in slope-intercept form, now you plot the negative 2, and then you're going to go up 4, right 3. So plot, put your first point at negative 2, and then you want to go, from there, you want to go up 4, right 3. One, two, three, four. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. So you can actually keep going until you get to that very top. And then I'm going to go back to my starting point, and I'm going to go down and left. So down 4, left 3, down 4, left 3. Okay, so their point of intersection, what is that ordered pair where they cross? 6, 6. So 6, 6 is the answer to that problem. That is the solution to the system. Alrighty, number 5. Both of these are in standard form, so I am going to have to change both of them in order to even get started here. So all I've done is I've taken both equations, written them down here, and I'm going to go ahead and move my stuff around. So for each of those, we're going to move the x term. So I'm going to subtract 1x here. And over here, I'm going to subtract 2x. So I'm going to finish the left one first, and then I'll finish up the right one. So the left one, we have 6y equals negative 1x plus 42. And then what would I divide everything by? Yep. Divide everything by 6. So we get y equals, now when you go to do your slope, if you only see one negative sign, it's going to remain negative. So negative 1/6 x. And then what's 42 divided by 6? Seven. Now this other one, after we subtract 2x, we have y equals. So look at that, you guys. We already have y equals. We won't have to do the division step. That's always nice. These two, they're not going to combine. You're just going to write them sideways. So you put the x term, which was negative 2x first, then minus 4. And now that one's ready to be graphed. So both of our equations are now in slope-intercept form. Okay? Ready? I'm going to graph this one first. I'm going to start at positive 7. Then I'm going to go down 1, right 6 as many times as I can, which is probably only once. So start at positive 7, down 1, right 6. Done. But I can go back to my starting point and go up 1 and left 6. All right. The second one was y equals negative 2x minus 4. So that one I'm going to start at negative 4. And with a slope of negative 2, I need to stick a 1 underneath it. So I'm going to go down 2, right 1. So down 2, right 1. Down 2, right 1. Down 2, right 1. And then I'm going to switch directions because right now it's hard to tell where it's going to cross. But I'm going to switch directions and go up 2, left 1. At least until I run into that other line, which is right there. It's almost up there at the top. So since those cross, their point of intersection is what? Negative 6, 8. Good job. Then we've got two more. No, I'm sorry. Just one more on the next page that are two equations, and then I think we switch to inequalities, right? Okay, so when you guys take a look at number 6, this one, the top one's in point slope, this one's in slope intercept. So actually, they're both ready to be graphed. You just graph them different ways. So let's start with the bottom one because this is the one we're most used to. This is the slope intercept one. We would start at positive 4, and if our slope is negative 1/2, that's down 1, right 2. So go ahead and do that if you haven't already. And then if I don't go down and right, we can do what? Up and left. You actually land all the way up there in the top left-hand corner. Now the one that's in point slope form, this one, they have given us an ordered pair of where we can start. So remember this X right here, that is the first one, but you have to make it its opposite. The Y right here is your second number, but you have to make it the opposite. And then this number right here in front of the parentheses, that is our slope. So you have everything you need to graph it We're going to start at -4, 1, which is located right there where I just put that first orange dot. So when you guys have point slope form, you know, most of the time you're not starting on the X or the Y axis. They're just giving you an ordered pair of where to start, and then we're going to use the slope. And if it's positive, upright. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. Now I'm going to go back here and I'm going to go down to left 1. But hopefully you guys have, I mean, you can already see, we already can see the point of intersection. But again, I think it's important that you guys just plot as many points that'll fit anyway. Like I said, it just makes it much more accurate of a line. Can somebody tell me what that ordered pair is, please? Where'd they cross? Right there? What is that? -2, 5. Yep. So that's what I'm going to be looking for. I'm going to be looking for you guys to write the ordered pair of where they cross. -2, 5. Now, when we switch to inequalities, so 7 through 10, these two, 7 and 8, they have just given you one inequality per problem, okay? So when you graph it, did you still need that one? Okay, here, I'll leave that up. When you guys graph 7, it is already in slope-intercept form. So you want to go ahead and graph it like always. You know, plot your y-intercept first, use the slope to plot all your other points. But then you need to figure out, is it going to be solid or dashed? You have to check it to know if you did it right. You have to figure out if it's solid or dashed, and then you're going to be shading one way or the other. You're either shading above your line or below your line. Okay, so you're going to plot your point at -1. My slope is negative, so we're going down and right. Down to right 5. You can only do that once. You can go up to left 5, but then you have to stop. You have to think to yourself, okay, since this has an equal sign, what kind of line is it? Is it solid or dashed? Solid. Anytime you have equal signs, it will be solid. Then the less than symbol, is that above or below? Below. Okay, so you're going to put your ruler down. You're going to make a solid line. And And then I think it's pretty obvious to tell, but where's the below? Up or down? Down. Remember yesterday in the notes they said just if you struggle with where the shading's supposed to go, below, just go to the line and just draw arrows facing down, and that'll show you where to do your shading. So we're going to shade this bottom section. Okay, then problem number 8, same type of problem, except what form is it in? What's this form called? Standard. We don't want it in standard. We want it in slope-intercept form. So wouldn't I subtract 1x first? Yes, we would. So then we would have 3y is greater than. These two you'd want to put with the x term first, then the 9. So negative 1x plus 9. What would I divide everything by? 3? No, you're right. Now look, since we're dividing by a positive, do I have to flip this symbol? Nope. It's going to stay greater. And then will negative 1/3 reduce at all? Nope. So negative 1/3 x. And what's 9 divided by 3? 3. Okay, now that one's ready to be graphed. Before I graph it, let's just talk about, is it going to be solid or dashed? Dashed, because there's no equal sign. And then greater than, is that above or below? That is above. Okay, so we're going to start at positive 3. And then we're going down and right. There's a lot of negative slopes. I think they tend to test you more on negative slopes because those are the ones people struggle with the most. But when it's negative, always go down right. So down 1, right 3, down 1, right 3. Or I can go up 1, left 3, up 1, left 3. Well, I didn't make a dot. Okay. Now, when you put the ruler down, it is dashed. So don't make a nice solid line. You just want to go through and make dashes in between the points. You know, these inequalities are going to be worth more than equations because there's a lot more involved. You have to know when to make it solid, when to make it dash. You have to know when to shade up and when to shade down. Okay, so this one, am I going up or down? For the shading. Up, yep, because it's above. So it's this top section up here. Everybody good with 7 and 8? Because the only thing left on the back are systems. So systems of inequalities. So you're going to have to graph 2 of them on the same coordinate plane and then do some shading. Okay, so this one's the nice one because this one, both of them are in the form we need them to be in to graph. These are both in standard form, so we'll have to move things around before we can actually do the graphing. But for number 9, let's start with the top one. Is that one going to be solid or dashed? It is solid, and then above or below? above because it's greater. All right, so start at positive 2. So right here. And then with a slope of 2/7, where are we going? Up, right, yep. Up 2, right 7. You can only do that once. But then I could go down to left 7. So down to left 7, and you can only do that once. We already said it was solid. So I'm going to go ahead and connect those. Make a solid line. And then yesterday, what I told you guys I typically do is I just write the letter A next to it for above. So that way later, I'll be able to tell where to shade. Now this one starts with the letter X. And when it starts with the letter X, where do we plot it? X-axis. So I'm going to go over here to the 7. And is it what kind of line? The vertical? Yep. Okay, now before I draw it, because I can just follow that grid line, solid or dashed? Solid. Above or below? Above. Okay, so I'm going to follow the grid line. I don't know why I'm trying to do that. Grid line. We've got our nice vertical line there. We are no longer looking for a point of intersection. We are looking for the section that the shading would overlap. So everybody watch. This is the part you need to pay attention to. What I did yesterday was I just took a pencil and I labeled my sections with like 1, 2, 3, 4. You know, your sections aren't always going to be the same size. Like this is just one little corner. This is a corner. Then you've got some bigger pieces here. I like to do it this way because then I can say, okay, pink line right here is above the pink line 1, 4 or 2, 3? 1, 4. So then I'll go over here and I'll just write 1, 4. Then for the green line, would above be to the right or to the left? It'd be to the right, which is 1, 2. Yes? So then which number do you see twice? 1. Section 1 is the only section that would need to be shaded. That would be the overlapped section. So then I usually just go back in here and do some erasing. Get rid of those other numbers just to clean it up a little bit. And that one's done. Number 10, even on your quiz, is going to be the one that requires the most work. It's going to take the longest amount of time. Both have to be changed. Good news is, look at what's in front of y. Aren't they both just 1s? So will we have to do the division step? Not on either of them. That's really nice. Whenever it's a positive 1y, you don't ever have to divide. As soon as you move the x, the y will already be by itself. Now, if there was a number in front of y, you would have to do the division. Okay, but once we change these, then we have to graph them both. We have to figure out which one's solid, which one's dashed. We have to figure out where the shading is. So this one's the hardest. Make sure you guys get all this written down. Okay, so I'm going to take both of these. I'm going to write them underneath just so I have room to work this out. Okay, so please make sure you're watching and writing this down. I would start by subtracting 5x, at least on this one. And when I do that, y comes down and the less than symbol. And then we have negative 5x plus 2. Now see what I'm saying? Yes, I could stick a 1 right here, but if I go through and divide by 1, nothing will change. It will stay exactly the same. So when you have just a positive y, you don't have to do the division. Okay, so let's get this one graphed first, and then we'll focus on the other one. Is this one going to be solid or dashed? Dashed, and will it be above or below? Below, because that's less than. Okay, so Trinity, you said start at +2. And if my slope is -5, isn't that -5 over 1? So we are going down 5, right 1. I think you can only do that once. 1, 2, 3, 4, 5, 1. And we can't go up 5, so those are the only 2 points that fit. Keep in mind, though, that when you connect these, you said dashed. So don't, it's a pain to have to fix if you make it solid first. If you make it dashed first and then you're like, oh wait, it's supposed to be solid, that's easy. But making a solid line and then fixing it to dashed can kind of be a pain. So make sure you pay attention before you actually connect those points. And we said what, below? So I'm going to go ahead and put a letter B next to that one for below. And then the last one, all I would have to do is subtract 1x. So I have y is less than or equal to -1x minus 2. And again, the y is by itself. We didn't have to worry about, oh, do I have to flip my symbol? Because we didn't even do the division step. But when do you flip the symbol? When you divide by what kind of number? Negative. Okay. Solid or dashed for this one? Solid, because it has an equal sign. Above or below? Below, that's less than. Remember, the one that looks like an L is less. Less. Less is below. Okay, start at -2. And if our slope is -1, that is -1 over 1, so that's down 1, right 1. You can do lots of points. Down 1, right 1, down 1, right 1, down 1, right 1. Never mind. James, I'm glad you were paying attention. I don't even know why I did that. Let's start again. I apparently don't know my right from left today. Okay, I was saying right even. Down 1, right 1. Down 1, right 1. Down 1, right 1. Now I can switch and go up 1, left 1. Goodness gracious. It's been a long, short week, hasn't it? No. Now we said this one was going to be solid. Now look up here, because this one's supposed to be shaded below also. There is a very tiny section right here. See this little piece? That is section, I'm going to call that section 1, section 2, section 3, section 4. Now, if I need to go below this blue line, is that 2, 3 or 1, 4? 2, 3. If I need to go below this purple line, 1, 2 or 3, 4? Below. 1, 2. So which one is doubled? Okay, section 2. Section 2 is the section that you need to shade. And then, like I said before, I usually go in here and just erase the other 3 numbers just to clean it up some. And I believe your quiz on Monday has exactly 10 problems just like this review did. And they will all be pretty much the same. Same type anyway. So I do suggest over the weekend making some notes regarding this review.